This is the 18th of November 2013. We're at Vincent Corporation. We have two presses set up here, two twin screw presses. And we're just starting to feed some Carrageenan in. We're running very low, 20 hertz, just to take it easy to start with. We're feeding it into the screened area of the press. And I'm drawing material out here, so I must close the cone. And close the cone. And see if we can squeeze any liquid out. We're getting liquid here. You see it starting to drip out. And we're getting the cake to come through. It is coming through. This initial test was just to see if the material would go through the press, and without jamming, we'll see if it keeps working. Okay, we're continuing to feed material in. Slow motion action here. We're getting liquid out, but only at the end of the screen. I did increase the air pressure to 4 bar. I'm getting quite a bit of solids coming through the screen opening. These slots are very narrow. I think they are 400 microns. The cake coming out here. Problem that we anticipated was that it would co-rotate with the screw and not come out. It's coming out okay, but I'm not getting out of nearly as much liquid as I would like to. Okay, now it's after lunch. Ran a moisture test. We got it. The solids went up to 25%. We're trying to get 30% solids. I'm squeezing the heck out of it. That is, over here I have a pressure multiplier. So I've got 10 bar. That's 15 times 10 is 150 psi. I have 10 bar pressure, that's a lot, and the cone is completely shut, and we're starting to feed in the material we ran before. It's a bit messier, but we're definitely squeezing out more water at the higher pressure. I should be able to achieve that with a different design screw. Best I can do right now is just run the air pressure up with that little pressure multiplier. Pressure multiplier is doubling the pressure. We have about 5 bar air pressure here in the factory. Here's what we're doing sample-wise. Weighs out to 1/1,000,000 of a kilo. We're taking some big samples that we will cook overnight, and we have some small samples that we will run for real quick analysis within an hour. And so we've got a lot of trays in here, and we'll see how these results turn out. Forgot to mention the oven is set at about 90 centigrade. And there's some samples I brought back from Moscow last week. That's coffee. And so this is where we run tests. This is the 19th of November 2013. Anyway, test results were terrible. The material we received was about 12.5% solids. At 100 bar, we only got it up to 18%. Nothing. Samples that we ran in the oven. And anyway, we're going to try something else now. We're in the test area. We've just been running samples of sweet potato. Just about finished. Low capacity. Notice this screw is coated almost like with porcelain glass. We get out good liquid, good cake. We aren't rotating the cone. So the sweet potato turned out well. We got about 40% by weight is liquid, and it was 60% by weight liquid, 40 cake. So that's a good separation. Yep, sweet potato press cake, sweet potato press liquor, and here we'll try the Carrageenan gel again. We're still in our first container, running it through multiple times till we find out what'll work. We've now programmed this press to go forward and backward. There it's going backwards real fast. I think we had to slow it down to 90 hertz, and then it goes forward for about 20 seconds. We'll see if that makes any difference. Good morning. This is the 20th of November, Wednesday, third day. We're going to try this press. It's still the first bucket of material. We've run it through these presses. But what we're going to do here is we have a firing mesh fabric in there. And we don't think this will work, but we are desperate. Oh, what we did we got up to 20% solids. In the material this material that we ran yesterday. Okay. I have the discharge cone open on this press. You can see an air cylinder will push it in. Go ahead and close it. No, if it does like the last time I ran a single screw press, it didn't work at all. We're starting to get a little stuff out here. So I'm going to close this cone. Very low air pressure. We're starting to get some water out. I expect this to blind over and stop real quick. The cone is trying to open. Water's started here and it's now progressed back to here. We'll see if it keeps creeping that way. Cake coming out. Very low air pressure, but I don't want to jam the press yet. We're up to 5 bar pressure and we're getting water out. Still getting it out down here. And we're getting it down here too. If this continues, it'll be amazing. This is still working. The fabric in there, that cloth, it's got a steel sleeve on the inside. Those little round steel holes are 1/2 millimeter, maybe more. And the fabric is something like 100 microns. So we don't have any solids coming through in this liquid. This press is set up for rotating cone. If this collar were engaged with that pin, this cone would turn. What we can see from this, the cake is coming out all the way around, so we don't need that rotating. Well, we could we'll hook up the rotating cone if we keep going with this. Now what's happening here is I'm getting more liquid out in here. I'm not getting much here anymore. We'll keep going. We could put the same kind of screen in a twin screw press. That is, it's reinforcing ribs, a reinforcing plate with holes that are a little less than a centimeter in diameter, a layer of fabric cloth, polyester, and then inside of that a sleeve of perforated sheet metal stainless with 1 millimeter or half a millimeter hole.
I think at .050 first, whatever that comes out in this millimeter.
That's a millimeter. Yes, the holes here are 1 millimeter, 1¼ millimeters actually. We're hooking up the rotating cone. What I forgot to mention is this screw is coated with the porcelain-like material, very smooth, and the screws in the twin screw presses that we've been testing with, only one of them actually, we polished the downstream surface of the flight, so it wasn't sandblasted, it was polished and smoothed out. That was to keep the material from getting stuck in the press. This is the fabric that we have in here. We're pretty sure this one in there is 43 microns. Okay, we've changed things. We now have the rotating cone in operation. Notice we're getting cake out. We're using our pressure multiplier again. We are at 10 bars pressure, 150 psi. And incidentally, we've never been able to make this fabric work before. It's the first time. And we'll see what we can do. Okay, we have decreased the air pressure to 5 bar, more reasonable number all the way around. We're not getting as much water as before. We'll keep an eye on this. Okay, we're down to 3 bar, but we have blinded off this fabric. That is the little tiny 1¼ millimeter holes. They're very thin, but they're probably packed solid with Carrageenan gel and keeping the water from coming through the fabric anymore. That's what the problem we've had every time we've tried this. Yeah. Open it up, Bill. You can see the bolts going around there. Those strip the cake away. That's why we like to rotate the cone. We're just emptying the machine out right now. Okay, we're putting packing foam into the press. It's a marker. We're running through all the old stuff we had. We are now up to, again, hooked up for 10 bar pressure. And we're squeezing the old stuff that we've run from the first container. We still have 3 containers to go. We're going to do a time capacity test on this press. We're running forward at 10 RPM, and we ramp down and ramp up at 1/2 second. It's a quick stop and a quick forward again to run backwards every 40 seconds. So you'll see it run backwards. It goes backwards 1 turn when it goes backwards. And once we see some styrofoam coming out here, we'll know that we have, we can start feeding in the, there it goes backwards. About 1 turn, then forward again. Okay, this is our timed test. I waited till I saw some styrofoam come out. In fact, there's a little bit of styrofoam down in there. And, but we're 17 seconds into a test, collecting the press liquor. This screen is obviously not good enough. 550 micron slots. It's the only ones we have for the twin screw 6. Our next test after this one, we are going to find a real fine screen in either a 4 or 6 inch press. and run that to see what the solids are like coming through the screen. There's the action of liquid coming out and cake. We've just completed our test. 2 minutes. In 2 minutes we got all of this and only this much liquid. We should have gotten a lot more liquid than that, but we'll see what it measures. Okay, this is our pressed liquor, getting a sample, so you can see how clear it is. Okay, now it's the next day, 21st of October, Thursday. Nellie, you will recognize this press, CP4. This one is special because the screw tapers down. Notice how short the flight is in there. It's only a tiny flight. So we've tapered the shaft. Also the screen is very fine, probably less than 250 microns. And so we're going to try this. It's a single screw press, so it may jam, but at least we'll see if we can make some dry cake. Okay, we're feeding in the cake from the second drum of material. Go ahead, Bill. I just ran it in at 3 bar. Now that liquid looks clear so far. We'll see what happens. The press jammed right away. That's all the cake that we got out. We're getting ready to try to build a tool to try and force that material into that CP4 press. This is the twin screw 6 that we've been using. Notice that we just took the screen off, but if I look here at the inlet, you can see what the shaft looks like, and down here at the end, you can see that the shaft tapers up. Not very good. So I don't have much taper. That's the trouble with this press. I needed a much greater taper, but we couldn't build it into this particular twin screw because the screws are too close together, and if we built this shaft up anymore, the flights from the other side would run into it. You see the difference there. What I'm saying is I think this press would work if we had the screws further apart so that we could have a bigger diameter screw at this end and squeeze the material tighter. It did feed very well because the flights of this screw overlap with the flights of the other screw, and so the other screw pushes the material along when it tries to co-rotate with one screw. We look around here, there's 2 screw presses, another, and you'll see dozens of screw presses. There's a couple of vapor-tight presses right there, some fiber filter machines. This is our overhead crane, and what we're trying to do is we're trying to duplicate what we do with a twin screw press. We've never done this before, but we'll see what happens.
You want me to turn it on before I start?
Yeah, turn on the... Okay, we've got the press going, and squeezing out the air because is it coming out through the seals housing, or that's it, huh? Well, we'll have to try a bigger weight. Nothing happened. While Bill's hunting for a bigger motor, this is our screw department. We have lots of screws. We make them from the flights, so you can see screw conveyor flights. Well, they're not screw conveyor flights, they're sectional helicoids. More screws. This is where we manufacture the screws. And anyway, we do have screws for screw presses. Notice the one in front has a tapered shaft and the one in back does not. So there you see an example of a tapered shaft screw. Here's another one, tapered shaft, and then the old standard, another tapered shaft. This is what they look like when they wear down, and this is what they look like when they break. Yeah, if some liquid had come through, we'd have something we could duplicate in a twin screw press, but we're not there yet. Press is going. It's a painful lift. Oh, we're getting water out. I see it's spitting. Look at that! Hot damn! Hot damn! Oh. It stopped. This is the Vincent factory, and we have chickens. There's a, yeah, these are all golden phoenix, and there's a turkin. Ever seen one of them? Okay, it's after lunch. We've installed a conventional screw in the CP4. You can see the higher flight than there was earlier today. Okay, we're running this at 2 bar. And getting a little bit of water out, not enough, but at least the cake is continuing to come on through. I'm going to increase the pressure until it looks like it stops coming out, then we'll stop the press, load it up, and try a heavy weight to see if we can keep it going. Okay, it's still feeding. I'm up to at least 4 bar. Continuing to work.
I feel like I'm slowly going down.
Yeah, the cake's coming out. And getting some more pressure here. We'll touch 4 bar now. And I'm up to 5 bar. And it's starting to stop, so we'll stop. Okay, we're at 5 bar, and that's as far as it goes. Okay, so we've done this. Go ahead and put in the stopper. You can see what we're doing. Okay, this is where I'm going to get my sample cake. I'm still getting clear liquid, not a whole lot of it. Trying to lower this motor down. Now this looks pretty good. Can you pull the motor down on your end, Bill? Get my samples. Okay, this looks very good. I see some water. Anyway, this is what I want. And at least it's continuing. Okay, you can stop it. Raise the motor or stop the press. What we're doing now is we're putting in some fresh material. This is our 3rd drum, and we're going to put on the pressure multiplier and get this up to 10 bar, and see if I can get some more fresh cake samples. Pressure multiplier, 10 bar. Squeezing it down. Come on, baby. Come out. Oh, we're getting some cake. Good. Okay.
Coming out at the beach place.
We're getting a press liquor sample. Solids turned out 3.5% on the stuff yesterday in the press liquor. My throughput capacity has gone down. At 5 bar I had good capacity in this press. I'm getting more stuff, a thicker press liquor, not enough press liquor. I'm afraid we've about lost it. We didn't do anything, but it started coming out, the cake. It's channeling, which we expect at high pressure, 10 bar. And we'll have enough material to get a sample. Terrible press liquor flow. So maybe we're not doing any dewatering. Yes, we're still running at 10 bar, and we're not getting any press liquor. The opening of the screen is 175 microns. So 10 bars is too much, but 5 bars we got good samples. We'll have a sample of this 10 bar stuff. This is the 22nd Friday, last day of this, well, we're not testing anymore. Wanted to show you how we polished the flights. Can you see the shiny metal in there? That is been polished. That was one of the details. We saved enough material to run another test in this press. I'll do that. It's in the refrigerator. And I need to get the throughput capacity at a much higher RPM. We've been running this press at 20 hertz, which turned out to be 10 RPM. I'll probably try 3 times that much and see what we get with the remaining material so that I can scale up to a full-size press requirement.